Some wave types we look at in EEG are beta, alpha, theta, and delta waves, as well as gamma. All of these types are distinguishable by their different frequencies and amplitudes, and the characteristic mental states they're associated with, although these are not always distinct and depend upon the region in which they occur. So let's go through them one at a time. Beta waves occur at a high frequency, so that means they're very busy, as opposed to longer, slower waves. They're going to have lots of activity in a small space, and there are lots of repetitions. They tend to be lower in amplitude. A trend in EEG is that the faster a wave occurs, the lower the amplitude tends to be. So the peaks are lower in voltage, in other words. Beta occurs predominantly during light sleep. Alpha waves, on the other hand, are lower in frequency and higher in amplitude than beta on average. They tend to indicate a relaxed state or perhaps mind wandering, and alpha increases when you close your eyes. Theta waves continue the trend here of being lower in frequency and than alpha, but not necessarily higher in amplitude. They usually denote drowsiness. And then delta waves are even lower in frequency, but very high in altitude. So they look like these large, slow waves. Delta occurs during deep sleep. So finally, gamma waves have the highest frequency and the lowest amplitude, but they're relatively new. The research backing them is more varied, and they've been associated with meditative state, but also muscle movement, which, as you may have picked up from our conversation so far, is a problem with EEG because muscle movements can corrupt a signal. The muscles generate so much electrical activity that it can overwrite the tiny signals coming from the brain. So that's something to keep in mind with gamma, and remains to be clarified. These frequency bands are useful in EEG because they're a covert way to tell us how alert or how well someone is concentrating during a task, and you can also detect clinical abnormalities such as sleep disturbances this way.